Creating the giant robots of science fiction is no small task. We want to believe that the robots from video games and movies are right around the corner, but the truth is, we still got a long way to go. Today, MegaBots is taking the first steps towards making giant mech combat a reality.
This isn't a walk in the park. There's no giant fighting robot industry or experts in the field. Yet we have to be careful in our design process because mistakes could cost us millions of dollars or worse, someone's life.
In case you missed it, we previously looked at how our old Mark II robot would do in combat. Unfortunately, in almost every test, our pilots either got seriously injured or died. And that's why we have to build an entirely new robot from scratch. Meet the Mark III. The key redesign features of the Mark III are pilot safety, modular arms, agility and advanced controls, and stability and traction.
The data from our Mark II testing showed that the cockpit needed a complete redesign for us to survive combat. We needed some help, so we brought on Lyra, our mechanical engineer, to come up with a new design. Lyra started the redesign process by studying different driver safety requirements of motorsports like NASCAR, Monster Jam, and Formula One. Once we had all of our requirements, she was able to mock up a full-scale model of our new cockpit.
Lyra, this mock-up looks awesome.
Thanks.
In our testing, the cannonball looked like it was the most fatal. Can you talk to us about how Matt's not going to catch a cannonball with his face?
Please don't let me die.
Yes, as you saw, it went straight through the front. To prevent that, we now have a layup of many materials. On the outside is metal armor plating. Behind that is polycarbonate or bulletproof glass. Behind that is a rubber spring dampening system to take out the shock load. And then behind that is the roll cage, which you can see the mock-up of right here. Anything that hits the slanted part of the canopy will also be sent off the top and ricochet.
So 4 layers of protection.
4 layers of protection.
So I remember from our previous test, the robot falling over was pretty traumatic for the pilot. What type of protections do we have to keep Guy and I from getting a concussion?
To reduce the shock that is going to get put into your bodies, we've got 2 major areas. On the exterior, we have the rubber dampener springs, and then on the inside, we've got these seats. They're designed to take shock that's in the roll cage and not spread it to you. There'll also be helmets, neck braces, 5-point harness, the whole 9 yards.
And how do we get in and out of this again?
All of the egress and ingress is designed according to Army specifications. The gunner can just come up to the nose and then hop straight in. The pilot comes up through the shoulder like this, opens the hatch, hops in, sits here. There's an emergency egress out the back. And then you can get from one seat to the other, just like that.
Sweet. Looks pretty easy.
Pretty easy.
So what do you think the chances are that Guy and I walk away from this without a concussion?
Significantly better than they were in the Mark II.
All right, great job.
Thanks.
Welcome to the armory. Our first weapon of choice is a heavy-duty, high-power stump grinder. We chose this trencher for its long range and potential to tear through robot armor. And this tree shear with 30 tons of cutting force can slice roll cage tubing clean in half. These logging grapples could be a way for the Mark III to hold the opponent in place and open them up for another attack. And this massive drill auger, well, you get the picture.
Oddly enough, none of these were actually designed for giant robot combat, so we have no idea if they're going to work or not. Therefore, we've designed the Mark III with modular arms to test all of these weapon systems and figure out what works. And we'll be showing you that in another episode. There's an old saying in boxing that the best defense is not getting hit. The Mark II had no good way to dodge a punch. Its ankles and its hips were frozen, and it could only sit down and stand up. We'd take every single hit right on the nose. We want to redesign the Mark III so it can bob and weave like a really big butterfly. We've designed the Mark III to be a humanoid robot, so it makes sense to study human combat techniques. And that's why we're going to throw our mechanical engineer, John, in the ring with a professional boxer and see what he can learn about punching and dodging.
Start off with the jab. You're going to extend and twist, and then it returns exactly back to your chin for defense. Always keep that stance and always readjust in between. It's going to be pivotal for your movement. Yeah, pivot. Yeah, this is one of your best methods of defense in boxing. Slip, 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 slip.
All right, John, what'd you learn?
Well, I learned that it's way easier to take notes on a clipboard when you're not wearing boxing gloves. I also learned that to be an effective fighter, a boxer needs to use his shoulders and his arms, his ankles, his knees, hips, his waist. If we're gonna make a giant fighting robot, we're gonna need all of those things. And all of that's gotta work together.
So you think we'll be able to dodge a punch?
We can make the robot float like a butterfly and sting like a bee.
Awesome. A really big bee. Let's do it.
The Mark III will be highly complex with over 20 joints and actuators. Coordinating motion in all of these joints would be way too much work for one driver to do manually. Miles, our electrical engineer, and the team at IHMC Robotics have been solving problems like these for decades. Think about when you walk. You don't think about the angle of your ankles, knees, and hips. Your brain coordinates all of that motion for you. In the same way, we need a centralized control system so that when the driver tells the robot, dodge to the right, the robot just does it. We've covered pilot safety in the cockpit, interchangeable weapons, agility of the robot's legs, and the beginnings of a centralized control system. But there's one last thing, the foundation of the robot. We need some new treads on this bad boy, and we think we know just the people who can help.